Welcome back to our next section of Math That Matters. This is lecture LA2. And Pete, what are we going to be talking about today?
Yeah, so we're going to jump right in. We're going to talk about three connectors. We've been looking at statements that are really simple called atomic statements, and then we're going to make them more complex, see how we can do that, and make what are called molecular statements. And then we're going to see how those statements can connect to each other. But our three main operators are going to be the and, the or, and the if-then. And we'll just start with the and. And we use these words all the time. So we're going to try to bring in situations where you would naturally use this, and then we'll just ask questions about the statement when it's true, when it's false, and then we'll make something called a truth table, which is kind of fun too.
Great.
Everybody loves truth tables.
Yeah.
So the and is called a conjunction. And the symbol that we use is that, which is sort of weird. It looks like a hat.
So when I see that in a mathematical statement,
in your head, yeah. So I'm just going to give you a simple statement.
Okay.
You go to dinner and you
Olive Garden.
order
Love
Olive Garden. Okay, you order soup and salad.
Usually they only give me one at Olive Garden, but you're telling me I can get both.
Yeah, in fact, you could get breadsticks with that
Okay,
too,
right.
right?
Soup
So
and
soup, salad, and breadsticks.
Okay.
Yeah, so you just order soup and salad. It's all you can eat, so it's fine. It's the cheapest thing on the menu. So this is good news. Soup and salad. Now, what we might do is we might put a letter for soup, like S would be soup. And is this symbol right here. And now, what would happen if I used S for salad?
No, that's going to confuse me.
That'd be terrible. It's called existential instantiation, as you might recall from...
I feel smarter just hearing that.
Yeah, it hurts a little bit, though. So maybe we would just use A for salad. So A is salad, S for soup. We're trying to take words and important logic words, operators, and put them into a symbolic state so that we can test them, so that we can do things with them. But before we do that, let me just see.
Is this a statement? Soup and salad.
Soup and salad.
According to our rules of statements.
So the waitress comes. You order soup and salad. The waitress comes, and would you say that it would be, when she gives you your food, that you would know if she did it or didn't do it?
Yes.
Yeah.
Yes or no?
Yeah. Now, we also want to know, what does it mean? Like, in what circumstances would you be happy and say, that's true, she did what I asked, soup and salad? And in what circumstances you would say, that's actually not true, I'm not happy with my order? So you tell me what would make you happy and what would make you unhappy.
Well, I just wanted to classify that it's a statement because it doesn't sound like one because it's not a complete sentence. But you might say, did you get soup and salad?
Yeah, did you get soup and salad?
Right,
well,
did you order soup and salad? Right, did you receive soup and salad? Those kinds of things.
Yeah, I suppose you could phrase it as
But
a question.
Questions.
Yeah, is it true that you got soup and salad? I'll phrase it that way.
Yeah, okay. And what's the significance of the and now? Because it's true or false.
This whole statement is true or false, but within that statement, this might be true or false. This also might be true or false.
I've got two things.
So in order for this statement to be true, obviously, both things have to happen.
Yeah, I have to get soup and salad to say true.
Right. So what we like to do is we like to make what's called a truth table and look at all possible scenarios to see if you're happy. In other words, the statement is true, you got what you ordered, or you're not happy because she didn't do what she was supposed to do.
You're going to show us how truth table works?
So I'm going to write this.
This is our first truth table. It's kind of exciting.
Yeah. Should I write it right here?
Right there, truth table.
Okay, so soup, salad, soup, and salad. And I'm going to make a little chart here. Now, let's see. Let's say it is true that she brought soup and it's true that she brought salad. Would you say it's true that she brought soup and salad?
Absolutely.
That's easy.
Yep, that's the easy one.
Now, isn't it possible that she could bring soup and not salad? So I'm going to write false for this not happening.
Good.
Now, would you say if she did this, that you'd be happy?
Well, depends on my diet, but I did not get soup and salad.
Yeah, not happy with the service.
That's right.
That's not what you ordered. So we would say soup and salad did not happen.
Yep.
It's false.
False.
It's false that you have soup and salad.
Right.
Or maybe there's no soup, but there is salad.
That's false.
So yeah, not. And maybe she doesn't bring any. Doesn't bring soup, doesn't bring salad, and of course that means
For sure not true.
for sure not
Yeah.
true.
I
That's a
noticed
truth
in
table.
making this truth table, and this will be helpful to you guys going forward, if we have two atomic pieces that make up a molecular statement, this pattern of true, true, false, false,
Yeah.
true, false, will make sure to give you all 4 possible permutations. So take a look at that and get used to that. You'll do it over and over. True, true, false, false, true, false, true, false. That way you make sure you got all the 4 combinations.
Yeah, because if you leave something out, then you're not going to be able to do the kinds of tests that we want to make.
Right. And I'm noticing, Pete, from the truth table that in order for the and to be true, the only way I can get a true in this column is if I got 2 trues here.
Both must
Yeah.
be present.
Any one of these
Yeah.
are not present. This is a false.
Now, I also want to talk about a negation. We said it informally.
Yep.
And a negation, we use this little tilde for negation. So I want to also include this in our truth table. I want to say, now this means not, which is sort of strange. Not means the opposite of soup and salad. So a lot of times in a truth table, we're going to write something, and then we want to write its opposite also, because we might care about that.
Good.
So what would the opposite of this situation be? It's actually the opposite of this, right?
Yeah, the opposite of soup and salad is the opposite of this letter.
Yeah, so whatever letter is right here, I just want to put the opposite right here,
Every
because
time.
literally those are opposite statements. So this would be false, true, true, and true. So in conclusion, at least for this part, we would just say that if you have an and statement, in order for the and statement to be true, both things must be present. If they're not both present, then we would say that and statement is false. And the other thing is that if you negate something, then immediately whatever truth value you have, it turns into the opposite one. Pretty straightforward.
Excellent.
So that's our first operator. That's the and statement.
Move on to the ors.
Let's move on to the or, and we'll do the same kind of thing
Good.
here. So we'll just say,
I'll clean the table up while
Okay,
you're right over
thanks.
there.
yeah, so the or statement is called a disjunction. And the symbol we use looks like a V. So suppose we took an example. Let's say you are ordering breakfast, and just before the waitress leaves, she says, would you like a biscuit or toast with that? She just used an or. So we would say biscuit or toast.
And I know what you're going to ask me. After the waiter or waitress walks away, delivered my order, did I get biscuits or toast?
Right. Well, are you
Okay.
happy? Are you happy? So we're going to have to look at every scenario, the ones maybe where you're happy and the ones where you're not happy.
Okay.
And I'm going to write it in symbols. So biscuits or toast. We've got B, we've got T. It's a molecular statement. And so let's just put them here in our truth table.
These don't change
Those
because
really-
they stay the same all the time. True, true, false, false, true, false, true, false.
Now,
I
of
have
course,
every
if you had
possible
another
combination.
statement, right, if we had like B and T and C, then we'd have
That's
more
advanced.
stuff.
We'll do that next time.
Okay, so let's do this. Biscuits or toast.
So you want to know when biscuits or toast is true and when it's false.
Yeah, so
I think I could just kind of figure that out, Pete. Like,
I think you
if I
could
got
too.
biscuits, then I got biscuits or toast. If I got toast, then I got biscuits or toast.
Sure. What if she just accidentally brought you both?
I'd be happy.
You'd be really happy.
Yeah.
Yeah,
I
so-
wouldn't tell her, by the way. I'd
yeah.
keep them both. Yeah. And then
Yeah.
you're asking me if that's true. Did I get biscuits or toast? Yes.
You did. So biscuits or toast is happy if you get one but not the other, if you get the other but not the one, or if you get both. The only instance where you're not happy is
I got nothing.
I got nothing.
Yeah.
Yeah, so biscuits or toast would be happy. And when I say happy, I really mean true. It would be true
Right.
when both came. It would be true when biscuits came but not toast. It's still true. It'd be true when biscuits
Yep.
didn't come but toast did. But
No deal.
no deal. Not too bad.
So I noticed something, Pete. In the and I wish we still had it up here.
Yeah.
But in the and, it was true only in one instance, and it was false for the other 3, and the or is the opposite. It's true in 3 of them.
It does
And
seem
false
like
in
there's
one.
a relationship
Yeah.
between ands and ors with the trues and falses being
Right.
flipped.
Yeah.
So maybe a negation.
Yeah. And it's much easier for this to be true.
Yeah,
So,
very much easier.
Okay, let's
How
try to
about-
practice the negation again, because this is confusing. If we put this in context and you say, Neal, did you not get biscuits or toast? I'm going to get like, what do you mean, did I not
Yeah.
get biscuits or toast? That sounds confusing.
Yeah, and one of the things, typically when you're teaching logic, at some point, it goes over your head. And either you just get confused and you give up, or you kind of make some little rules for yourself and you say, at this point, I'm just going to follow the rule. I'm not going to confuse myself. So if you can think through it really well and your intuition just kicks in and you got that particular type of smart gene, that's great. If you don't and you say, I'm doing the not of something, just change it to the opposite. So this T turns into an F, and this T turns into an F, and this T turns into an F, and this F turns into a T. Pretty straightforward. So would you prefer to think through this, or would you prefer to just change it from what it is to the opposite?
Yeah, the way for me to see the not is to get the or first and then just switch the sign, as opposed to think through it intuitively, which is what we want to encourage you to do.
At some point, if you don't have some little rules that say, just do this, you just get caught up in doing something that might get in the way of something else that's more interesting or more complex.
Okay, so that's your second truth
that's
table.
Number 2. And we're going to do the third one, which is a little more
It's the
tricky.
big guy.
It's the
Okay.
big one. Thank you. So let's talk about an if-then statement. If-then statements are called conditional statements. And I'm just going to write one. So let's say, let's talk about my sleeping problems. Again, I've had sleeping problems forever, and everything seems to give me a sleeping problem. So if I sleep on my back, then I will wake up during the night. It's actually true.
Okay.
And they tell me not to sleep on my back. I start choking in the middle of the night. So
if I sleep on my back,
I sleep on my back.
and I'm going to get good at putting symbols on here. B, let's call that a B.
We'll just call B.
Okay.
Then I will
Good job,
not
down
sleep,
there.
right?
Then what?
Then I will wake up.
Okay.
Then I will wake up.
Call that a W for wake up. How's that sound?
Yeah, I will wake up
Okay.
in the middle of the night.
By the way, is this a statement?
It is.
Yeah.
Yeah, I sleep on my back. Either I do or I don't.
I wake up.
Yeah.
So we have two statements.
Two atomic statements put together with an if-then in a cause and effect relationship. In fact, the if part is called the antecedent, the thing that creates the cause, and then, or the cause, and then this is called the consequence of the cause, the effect.
And what we're going for here is not is this true or is this true, but is this true?
Yeah. Did I tell you the truth or did I lie? So in order to represent an if-then statement in symbols, we use an arrow.
That makes sense to me.
I like that.
The upside down caret still makes
Yeah.
sense. This one makes sense.
This just means that B leads to W.
If B, then W.
W is a result of B.
Okay.
So we've got two atomic statements, B and W.
And these are the four combinations of them
Right.
again. Either I sleep on my back and I wake up, I sleep on my back and I don't wake up, I don't sleep on my back and I wake up, or I don't sleep on my back and I don't wake up.
Nothing else could happen,
that's
right?
it.
That's
Every
everything
possible
that's possible.
variation.
So now this is actually pretty tricky.
Okay, let's take some time on this one, unpacking this.
If B, then W. We're
I'll
trying
be
to
your right. What do you
decide
think?
if this is true or not. So let's say for this, you come and you watch me sleep all night. You're there for all 4.5 hours that I sleep.
Okay, got it.
And you're watching, and all night I do sleep on my back, and you notice that I wake up.
Then this is a true statement, I would say.
I would say so too.
Good.
Yeah.
Got it.
Yeah.
Okay, option 2.
Option 2.
I watched you all night.
I do sleep on my back,
Yep.
and I don't wake up. What would you say? What would you call me?
Well, I'm glad you didn't wake up, first of all. But I would say this statement, although this was true, this statement was a lie.
You would call me a liar,
It
wouldn't
was not
you?
true.
It
It was
hurts, you know.
false.
I thought we were better friends
No,
than that.
I'm sorry, Pete, but you lied. You lied because you
I-
said if this, then this, and you gave me if this, but not this.
Yeah, in other
That's a
words,
false.
this did not cause this.
Yep.
Or you could say, this did not follow that.
Okay.
You watch me all night and you're like, oh, wow, he did not sleep on
Didn't
his
sleep on your
back,
back at all. Yeah.
but he did wake up.
And now you want to ask me, is this true if you didn't sleep on your back, but you did wake up?
What would you say?
Pete, it's not true, but it's not false.
Isn't that weird?
You're giving me two choices, true and false. It's kind of gray.
It feels strange.
Yeah.
Now, is there some way you could say it's either more true, seemingly more true, or more false? Could you call me a liar?
No, you didn't lie to me, because your statement was that, Neal, if I sleep on my back, I'm waking up. And you didn't sleep on your back, so you didn't lie to me. So that makes me want to call it true, but this didn't happen.
I know, it's sort of strange.
Yeah.
But the statement never had a chance to be true.
That's right.
I'm sorry, it never had a chance to be false.
Because you didn't sleep on your back.
Right,
Yeah.
right.
Yeah.
So whenever you can say that I'm a liar, then an if-then statement is false. But if you can't say that I'm a liar, the if-then statement has got to be classified as true.
This is going to bug you, and we're
I'm not
okay
gonna
with
like
that.
it.
This is mathematical thinking, though. This is just mathematical definition,
Yeah.
right? We're more concerned, I think, about was it a lie or not, which is what you're
Right.
stressing,
Yeah,
instead of saying it was true. It's true because it wasn't false.
yeah, that's a strange thing. It's
Okay.
actually called vacuous truth, and it means that you sort of have a vacuum as to whether you can classify this statement as false or not, because the thing that was the part of the if never occurred. So you couldn't say that this didn't follow this because this never happened.
So this is a genuine rule. Can you tell me if the antecedent
Yeah, if the if
is
part,
false?
then the
I don't
statement is
need
true.
to read this. Then
Yeah.
it's true. Okay.
that is
Well, then
correct.
I know this one
Yeah, what is it?
because it's true because the antecedent is false. It never
Right.
happened. So that's
So,
guaranteed.
so whenever you see an F on the if part, immediately you get true for the statement.
So be careful on these two and just trust us and run with it. Now, Pete, this is interesting, and I know this is really important to you, and this is a key point, that there is one way for this to be false.
Exactly.
Only
So
one.
anytime you're trying to classify an if-then statement, what I always do is I always just say there's only one way this can be false, and that is when I have a true-false pair. If this is happening, but this isn't, that means this is not following that. So I just look for a TF.
So
And there it is.
I'm going to fill this out again, and if I'm Pete,
Okay.
I'm coming in here saying
Yeah.
I'm trying to prove this conditional
Yeah.
statement. You're scanning and you're zoning in on that.
Yep.
Right there's the lie. You're calling that false,
Right.
and then you're just writing three truths
Yeah.
in.
You don't even have to think about the T's. So that's
Yeah.
my little rule is I just say, where's the true-false pair? Oh, it's right there. That means W is not following B, so the statement is false. And everywhere else it's true.
Vacuous truth. Okay, I know
And
we
one
love to
more,
do now.
we always have to negate things to see what happens.
This is confusing, P. What does not sleep on my back, then I will wake
Yeah.
up even mean?
Yeah. And what we're going to do actually is we're going to just remind you that the opposite of something means to change the letters to the opposites.
Okay.
And then in the next lecture, what we'll do is we'll kind of rewrite this a new way
Good.
that will make more sense.
Yeah, for now, it's okay to be a little bit confused on this, but we just want you to know, for now, negation is the opposite of the affirmation of it
Yeah.
happening. False,
False,
True,
false,
false,
and
false.
false. There it
And
is.
this kind of makes sense to me because you told me there was only one way that person lied, and the negation is the opposite
Yeah,
of the
only
truth.
one way
So
it
there
can be
is.
true.
Yeah. Okay.
Perfect. Well, I think that's about it. Do they have enough to do the problems on the take-home quiz questions?
I think so. I think we unpacked the three logical operators, and they're ready to go to work now.
Yep, we believe in you.
See you next class.